This is my testing for the computer science project. So when you load the simulation, you have the main menu where you can choose to play, load, see a help screen, or quit. If you press quit, the program correctly quits. If we rerun it again, we press play, it shows you different save slots that you can select and choose, which is just as outlined in the objectives. Now you can press back or you can press escape to go back. So if we press play and we select a save slot, for example, slot number 2, we are then asked to select a preset. I will select Lone Island for this. And then the main simulation starts. You can see that the food spawns pretty equally. So food spawns should be spread equally across time. What I mainly mean by that is that it shouldn't be that after 1 second all the food spawns and then for 1 second there's no food and then only at the end of the second all of this food spawns. You can see that as the game progresses, the time increases, the creature number changes as they increase or die. And the species number is currently only 2 because there's only 2 species. And the food number goes up at a pretty constant rate. There's 2 buttons here. One is to pause the game, and then you can also control it using the spacebar. There's also another button to increase the speed of the game if you want it to run faster. At higher speeds, the game does lag a lot, which is mainly due to the fact that it needs to do these processes multiple times per second. You can also control it with the plus and minus buttons on the keyboard. There's also another button, the graph button, which takes you here and you can look through the different graphs, and as the game actually progresses, these graphs increase. Now, one very important thing is that I want the game to be able to save itself whenever the user presses a button. So the button to save is 0, and when you do press it, the game saves, and if you press escape and you go to load the second simulation, you can see that it loads exactly as it was. And I can demonstrate this by quitting and reloading the entire program. Slot number 2 is April. You load it, and exactly as it was before, it is now the same. I will load a new save from the random preset, and the random preset gives you a random assortment of creatures every single time. Now, what's important to see is that the graphs, as the time increases, for example, right now, it's only been 15 seconds of the simulation. So the graph has a pretty precise, um, the graph is pretty precise. Whereas, and what I mean by precise is that it shows you in seconds. And then every dot here, every time the line changes, that's 1 point on the graph. Now, as the time increases, as we head into minutes, it stops measuring it in seconds and now starts measuring it in minutes. You can see 1 minute, 1.5, 2 minutes. And right now, it's very precise. So every single point is around 1 second or 5 seconds, I believe. However, I have laid it out in the design. So the reason I do this is obviously because if we get this same precision and it gets to an hour, the graph is going to look very squashed and you're not really going to be able to tell anything from looking at the graph. So now I'm going to enter debug mode by pressing Q. And this shows you different pieces of information about the creatures. Oh, and when you hover over the creature, you get the statistics, which is the ID, the generation, the energy, the current position of the center point, the genes, so the color, size, speed, the energy consumption, and what the debug mode shows, what these different circles show is, so the white circle is the actual creature like area, the hitbox. So it is bigger than the texture. So if another creature falls, like this part gets seen by another creature, then it counts as seeing this creature. The green is the actual vision radius from the center. And then here, this is where the creature actually will see different objects, different entities. And then the red is mainly for the search box of the creature, since it does perform a range search every single time. And it is a circle, however, the actual thing is a box, so you will be able to see that some get selected that are outside the circle, but they are boxes that it's supposed to be that way. This was mainly done just for me to be able to see and debug the different behaviors of the creatures. There's also different numbers. So the first number is the degrees where it's facing. Then you have the reaction of the creature, the previous reaction of the creature. It's either -1 or 1. -1 would be to react away from something, for example, react away from the food. 1 would be to react and turn towards the food. The last one is the energy of the creature, which now you can also check by checking the creature stats. So when you look at the creatures, you can see that the dark purple is all of the pieces of food that are selected. Now they do have an offset of 1 pixel upwards. So for example, it selects this one, but it shows here. All of these purple ones are every single entity that's selected within the range search. And then light purple is every entity that is within the vision radius. So I will actually enter a different simulation because Lone Island is easier to actually debug since there's a lot more food spawning. So as we can see here, the creature does correctly see that these entities, they fall within its radius, and these ones fall within the actual vision. And then it selects one random one from all of these red ones to actually react, either towards or away. Now, creature reactions, they depend on their genes because they have a turning speed. So sometimes the creature may react towards but not be able to turn towards the piece of food because it simply cannot turn fast enough. Now, we just saw two creatures bump into each other and they both change their direction. This is expected and is supposed to happen because when creatures bump into each other, they obviously shouldn't travel, go through each other. Now, whenever they bump into each other, there's also a chance that they will make a child if they have enough energy, and the chance happens. And we just saw that whenever the creatures hit the wall, they also bounce off the wall. So the creatures do have genes, and they do mutate as new children are made. Let's see if we can demonstrate this. In this case, we can see that the mutation has gone through and some of the genes have stayed the same while some others have changed. And these mutations are very slight, they're very small, but over time they're supposed to increase. The creatures do have a brain. As we demonstrated, the vision is a cone and they can see both other creatures and food. Creatures should have an energy which depletes as time moves on. We can see this by following this creature, that its energy is indeed decreasing. That as this creature eats food, its energy will increase. And we can see this creature has a very good, it's very accurate because it can turn fast and move fast. So it's just now avoided the piece of food. And it keeps avoiding pieces of food because that's what its brain is telling it to do. So when the creatures eat food, their energy is increased. They do bounce off the world border and they do give birth to other creatures in a way that was described in the design. So species so I've just found two creatures that have made two children, and we can see that this creature is species 1 and this is species 4, and these are species 2 because their genes are in the end closer to species number 2, and so that's why they are assigned that species. We can also see their generation increases. So that was it for all the objectives and all the testing. The simulation works just as expected. All the creatures move around as expected. There is one bug. Happens sometimes when the creature has a very low angle with the border and they just glitch and they start spinning really fast like this. But eventually they do get out of that spinning.